CI failures jumped from 2 per week to 12 per week after a pre-commit hook was introduced. The culprit? A 3-minute test suite that made every developer bypass all hooks, including Commit-msg enforcement. Let's break down Git Hooks Explained, how it works, and the exact mistake behind that failure. Git hooks are scripts that Git fires automatically before or after actions like commit, push, or merge. They live in the Git hooks folder of every repository. If the script exits with code 0, Git continues. Any non-zero code cancels the operation. They're your first line of defense for enforcing team policies. There are many hook types, but the most useful are pre-commit for fast checks, Commit-msg for message validation, pre-push for heavier tests, and pre-receive for server-side enforcement that cannot be bypassed. Every Git repo has a Git hooks directory with sample scripts. To activate a hook, remove the sample extension and make it executable. But these files are not pushed to the remote, so you need a strategy to share hooks with your team. Here's a simple pre-commit hook that checks for debug statements and merge conflict markers. After creating the file and making it executable, any commit will run these checks. Client-side hooks run locally. They're great for fast checks like linting, but developers can skip them with no verify. If your hook takes more than a few seconds, developers will bypass it. This pre-commit hook runs EaseLint only on staged JavaScript and TypeScript files. It uses Git diff cache to get the list of staged files, keeping the check fast. The Commit-msg hook fires after you write your commit message, but before the commit is saved. Git passes the path to a temporary file containing the message as the first argument. This hook is perfect for enforcing conventional commits, which powers automated release tools. This script reads the commit message from the file path in $1, extracts the first line, and checks it against a regex for conventional commits. If it doesn't match, the commit is rejected with a helpful message. Server-side hooks run on the remote repository after a push, but before the refs are updated. They cannot be skipped with any client flag, making them the only truly unbypassable enforcement. The pre-receive hook runs once per push, while update runs once per branch or tag. This pre-receive hook enforces 3 rules: no direct pushes to main, no force pushes, and branch names must follow a convention. It reads each ref from stdin and rejects the entire push if any rule fails. Client-side hooks are helpers, server-side hooks are enforcers. Always duplicate critical checks on the server. CI pipelines provide an additional layer that cannot be bypassed. This is the same issue we highlighted at the start. Here's exactly why that happened. The team lead added a pre-commit hook that ran the full test suite. It took 3 minutes on developer laptops. Developers committing 15-20 times a day lost nearly an hour. Within 3 days, everyone discovered no verify, which skips all client-side hooks. Broken code and bad commit messages reached the remote, and CI caught them 20 minutes later, making the problem worse. A 3-minute pre-commit hook running the full test suite caused developers to bypass all client-side hooks with no verify, breaking Commit-msg enforcement and flooding CI with failures. The fix was simple: move the full test suite to pre-push, which runs only when pushing, not on every commit. Replace pre-commit with a fast EaseLint check. The Commit-msg hook was reinstated because it adds 0 latency. Developers stopped bypassing hooks because they were fast. If your pre-commit hook runs the entire test suite, it will take minutes. Developers will quickly learn to use no verify, defeating the purpose. Keep pre-commit under 5 seconds. The core.hooksPath config option was introduced in Git 2.9, 2016. If your team uses an older Git version, this setting is ignored and hooks must be symlinked manually. Always verify the Git version with Git version before relying on this feature. The article mentions detecting bypassed hooks in CI but doesn't show how. This snippet runs the same lint checks in CI and fails the build if lint errors exist, effectively catching no verify usage. In production, monitor hook execution times. A hook that suddenly takes longer, e.g., due to a dependency update, will cause widespread bypasses. Use time in CI to track hook duration and alert if it exceeds a threshold, e.g., 10 seconds for pre-commit. If a hook isn't running, first check it's executable and has a valid shebang. You can run the hook directly with bash x to see debug output. Use time to measure how long it takes. Let's run through some common interview questions. What is a Git hook? Executable script that runs on Git events. How to share hooks with a team? Use core.hooksPath or Husky. Can server-side hooks be bypassed? No, they run on the server. And a few frequently asked questions. How to skip a hook? Git commit no verify. Can hooks be written in Python? Yes, any executable script works. What's the difference between pre-commit and pre-push? Pre-commit for fast checks, pre-push for heavy tests. To sum up, Git hooks are simple scripts that enforce quality gates. Keep client-side hooks fast to avoid bypass and always duplicate critical checks on the server. Use core.hooksPath to share hooks with your team. Ready to go deeper? Up next, Git clone. Clone a repository step by step, then Git pull. Fetch and merge remote changes, then Git checkout B, creating and switching branches. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.